All right, so for the next couple modules, we're going to be learning about systems of equations. So this lesson is all about introducing the system of equations and what they are and what they look like. So our goals are, I know what a system of equations is and what it looks like. And then we also want to say, I know that there are three types of solutions to a system of equations. So we're going to go through those different scenarios, compare them, and see what these all look like. So here is some vocabulary. What is a system of equations? A system of linear equations is a set of... Oh, I guess I got to choose my color. Two or more linear equations that use the same variables. All right, so you'll see an example mathematically in just a sec. A solution to a system of equations is an ordered pair that makes all equations in the system true at the same time. Okay, so basically we're finding an x and a y that we can plug in to all the equations, and all the equations would be correct using the same coordinate, or ordered pair. Graphically, the way we find a solution would be is where the point, so the solution is the point where the two lines cross or intersect. Okay, and then when we're trying to solve things algebraically, when you plug the x and y values into the equations, both sides of the equal sign are true. Meaning everything works out and everything equals each other. So we're going to learn how to solve these systems of equations using graphics, or using graphs, and using algebra. So for the graphs, we're going to look where they cross. For algebra, we're going to use a couple different methods to find x and y, and then plug an x, y back in just to make sure it's true for all of the equations involved in our system. Okay, so here's a couple examples of systems of equations. So here on our first example, we have y equals 3x minus 2 and y equals negative x plus 6. So those are two equations into one system. Notice that those are both in slope-intercept form. Here's another type, 2x plus 3y equals 12, x minus y equals 1. Notice those are in standard form. Here's another example of a system of equations. Y minus 4 equals 2 times x minus 1, and y plus 2 equals 1/3 times x minus 2. Hopefully you notice that those are both in point-slope form. And then we can also compare linear equations using different forms. Like this top one right here is a slope-intercept form, and this one right here is point-slope form. Here's another example. Here we have standard form being compared to slope-intercept form. So it's just a bunch of equations. We're going to just be dealing with two mainly for this class. But it's a group, it's like two equations that are putting together to make one system. And we have to find what x and y can we find, put in like right here and here, that would make that entire statement true. All right, so whenever we solve a system of equations, we're going to have three different types of solutions. The first type is when we're just going to get a regular one solution where you're going to find an x and a y. The way you can tell you're going to get just an x and y for a solution is if the lines at exactly one point are crossing. Or, right here, if the lines have different slopes. Or in algebra, you find one specific value for x and y that make the system true. You know you're going to get a no solution if the lines are parallel and never touch. Graphically, you could say it's the lines have the same slope, but different y-intercepts. And algebraically, you're going to get variables that cancel out, and you're left with a false statement. What that means is in the end, you're going to get something like 3 equals negative 2 after you try to solve for x and y. And we know that's not true, which means there would be no solution. If we want to get an answer for infinite solutions, that's when lines are exactly the same thing. The lines have the same slope, they have the same y-intercept, and then if we're trying to solve it algebraically, everything will cancel out and you'll be left with a true statement. So for example, at the very end of the statement, you're going to get something like 3 equals 3, which is true. If you ever get something like that in algebra where everything cancels out, but you're left with something that's true, that means there's an infinite amount of solutions that you could choose from to actually be the solution for that system of equations. So I put it in a table right here to hopefully organize it a little better for us. So if something has one solution, the graphing appearance means lines are intersecting in one spot. If you're looking at the actual equation, you're going to have a different slope, and the y-intercepts are any, meaning they could be different y-intercepts, or they could be the same. Okay, so this is when we're looking at the equation right here. And right here is when we're looking at the graph. So if our solution is going to be no solution, that means the lines are going to be parallel. If you have parallel lines, then that means you have no solution. Unless, the only difference is if the y-intercepts are the same, if it's the exact same line, then you'd have infinite solutions. So if you have parallel lines, or if you're looking at the equation, and the slopes are the same, but the y-intercepts are different, that means we're going to have no solution. Okay? And we will get infinite solutions if you look at the graph and they're the exact same lines. There'll just be one right on top of another. It'll look like there's only one line. If you're looking at the equation, that means the slope's the same and the y-intercepts are the same. That means I will have an infinite amount of solutions to that system of equations. So let's take a look at these algebraically. How many solutions do the following systems have? Notice, in this case, I just put everything in slope-intercept form. So what I want you to do is I want you to pay attention to the slope. Okay, what's the slope over here? This has a slope of 2. This has a slope of 2. Okay, if I come back here, it has the same slope. Okay, so since it has the same slope, we're either going to have no solution or an infinite amount of solutions. Well, let's take a look at the y-intercept. We have a +3 and a -5. Those are different. So if I have the same slope and a different y-intercept, what does that mean? That means I have no solution. So if I were to graph these, they would be parallel, they would never cross, and they'd have different y-intercepts. So here I have no solution. Okay, let's take a look at this next one. All right, so compare the slopes first. So we have a -3 to a 1/2. These are different slopes. If you come back here, if the slope is different, what does that mean? That means we are going to get at least one solution. Okay, so here I'm going to say we're going to have one solution. I said at least one solution. I didn't mean that. It's going to be exactly one solution. We don't know what that solution is yet. We're going to solve this later. Right now, I just want you to be able to look at these and see, oh, that's going to have one solution. And then you can solve for it. Or look and be like, oh, that one's not going to have a solution because of this. Or you can look at it and say, oh, that's an infinite solutions because of our table and what it's telling us. Okay, let's look at this one right here. Y equals 3x minus 5, y equals 3x minus 5. Hopefully you can tell right away those are the same lines because we have the same slope and we have the same y-intercept. Same slope, same y-intercept. If I come back to here, same slope, same y-intercept. That means there will be an infinite amount of solutions. So we just say infinite solutions. Okay, let's take a look at our last one. This slope and this slope's the same, but the y-intercepts are different. Same slope, different y-intercept. That means we are going to have no solution because they will never cross. The majority of what we're going to do, though, the majority of everything we're going to look at is going to be ones like these, where we're going to have one solution. And then we have to solve to figure out what that one solution is. So the majority are going to look like this, where we actually have to solve for a solution and figure out where they cross on your graph. So for your assignment today, all you're doing is you're going to be comparing graphs and telling me, is there one solution to that system? Is there no solutions to that system? Or are there infinite amounts of solutions to that system? So I know what a system equation is and what it looks like. So that's when we're just comparing two different equations. Okay. And I know that there are three types of solutions to a system of equations. So let's look at this last one and then we'll be done with this video. Look at your slopes. They're different. Right? When you see different slopes, that should automatically mean, oops, I know that there's going to be one solution to this system of equations. And then we're going to learn how to solve to figure out what that one solution is. So go ahead and do your assignment and reach out if you have any questions.